Hello everyone, good evening. Is everybody able to hear me? Okay, thank you. All right, so yeah, it's 5:01 now, so I think we can slowly get started. Okay, so welcome to our first CS2100 recitation session. All right, so we're going to start things a bit slow, all right, and cover some of the things that we have covered. And I'll talk a bit about this module and my experience with this module as well, so you know what to expect and how it's going to be. Okay. So let me share my screen first. Okay, so this module, okay, yeah, so maybe before we start, okay, why this recitation session is not is 1 hour later than the current one that is going on is because of I was allocated this module sort of in the last minute, all right, and by that time I already had another module where I have Tuesdays and Thursdays labs from 2 to 5 at engineering site. So I'm still at the engineering lab, you know. So the only way, so after discussing with Colin, the only way we decided that we can do this is if I end my lab and straight away start an online session, you know. So that's the reason. Of course, preferably I would have liked a face-to-face lecture, you know, since we haven't had it for so long. But due to the timetable clash, I have to do it online. All right. So this module CS2100 is something that I have done, I think in a few years back, 2017 or 18, 19, I think. Yeah, 2018, 2019, around there, I did it for about 3 semesters. One semester I co-taught with Wang Fai, and another 2 semesters I did it fully. That means I was the lone sort of lecturer managing the whole module. And I think that time it was still manageable because at that time the intake was about 250 students or something, okay, taking this module. Okay, now it's like 3 times as much. Okay, so we needed more manpower. Okay, so that's why I'm back to help out with this module. All right. So this module CS2100, historically, many CS students always ask the question, why? You know, why must I take this? You know, it is not part of your comfort zone, as I would say. All right. And I think Colin also mentioned this probably in his first lecture, that the reason why it is important for CS students to take this module is because it's probably the only module, okay, that you may take where you actually get to learn the sort of the back-end hardware stuff, okay, on what goes on in a computing platform. All right. I mean, all of you are very, very good, very proficient in software development, algorithms, the maths, all of those stuff, you know. So that is your comfort zone, that is your sort of expertise. All right, but in this module, we are going deep into the hardware, the architecture of a computing system, a processor, and so on. And it sort of gives you a very good perspective of why sometimes the software that you write may not be consistent across different platforms. Okay, what is the reason? So what are the hardware differences between platforms that makes your same code have different sort of behavior or different performance in different systems? All right, so I think that is something you will get to appreciate as we go through this module. Okay, of course there will be many sort of things that you may be not comfortable with, not familiar with, and in a sense it may be a bit challenging as well. Okay, but I think the way it has been structured, you have sufficient help to manage and understand what's going on. Okay, so this is the first time I'm also doing this in this blended learning format. All right, so previously when I did this, it was the normal way. So we had 2-hour lectures where I covered all the material, then we had tutorials, we had labs. Okay, so now in this blended learning mode, basically what happens is you're supposed to view the lectures and attempt the quizzes. All right, these sessions are here to discuss and clear your doubts and reinforce the concepts. Okay, so whatever questions you put in the Slido, I will also have a look, correct, for each lecture slides, and then we will sort of consolidate and we will discuss them. All right, and we also have some practice questions and some other things to discuss. Okay, so my name is Mr. Ravi. All right, so my office is at COM20336. I guess I'm one of the few who did not jump to COM3. When COM3 opened, they asked us whether you want to move. I decided not to move, so I'm still there. Okay, yeah. So you can take note of my handphone number here. All right. So if you have anything that you want to clarify, you are free to WhatsApp me. I'm also part of the Telegram group, but with so many people there, sometimes you put a message there, you can get lost. All right. So I would normally prefer consultation by email or by WhatsApp. Okay. So if it is something quite detailed, then you put in the email. I think it's easier. If you just have a short, simple question, you can just WhatsApp me and I will usually reply sometimes quite quickly, sometimes a bit later, depending on what I'm doing. All right, so I'm generally more of a computer engineering guy. All right, so I do embedded systems, robotics, mechatronics, and so on. Prior to academics, I was in the industry. Generally, I like to do in my spare time, get involved in health and fitness stuff. Okay, so that's about me. All right, so again, just take note of my phone number. So if anything, you can just WhatsApp me. I think in the past, I've always given my number to my students, so it's easy for you all to contact me and ask for clarifications for anything. Okay, so I just want to have a sense of your take on this module so far. Okay, and okay, I'm using poll everywhere. Okay, and the reason why I'm using poll everywhere is because the Slido there's only one account, so currently Colin is using it, so I can't use that same account at the same time. Okay. Yeah, so if you can give me some feedback on what you feel about the module so far, I think that will give us a sense of again, this mood will change. So much content, yes, trust me, it's going to get more. Okay, there's going to get a lot more. Okay. Yeah, I think content is definitely the one thing that most students always say. Okay, there's too much of stuff, and I understand, but we really have a lot of things to cover. Correct, so that is why we have so much of content. Yeah, I hate C. Okay, don't worry. Okay, you can't you still have to come back to C when you do 2106. Okay, operating systems. Okay, too much lecture. Yeah, I mean, I guess when we do the recitation and we do the tutorials, I think you will tend to see that, okay, as long as you understand the practical aspects and you know how to apply it, okay, then you won't feel there is so much of content. The initial part, there's a lot of content because of all the concepts, okay, but once you start the practicing and so on, then I think it gets easier. Okay, so let's go through. Okay, so I went through your Slido questions. Okay, so what I will be doing is, instead of going through each and every sort of question posted on Slido, okay, I will consolidate the key concepts that I saw the questions were coming at. Okay, and then I think that will be easier for us to discuss on what is important. All right. Okay, so the first thing, just give me a minute here. Yeah, because I know I'm in my office, I'm in the lab, so I have to quickly put together a second monitor and set up my workstation here. Okay, so one of the common questions I saw in Slido is this concept of people not being clear on what is overflow or what is carry, okay, or what is the logic behind it. Okay, so the general way you can think of this is carry is and overflow is applied in two different concepts. Okay, carry is when you are dealing with this idea of what we call unsigned numbers. Okay, and overflow is when you're dealing with signed numbers. So what are signed and unsigned, correct? So unsigned numbers are when you have all the numbers being in the positive range. Okay, so for example, okay, if I have a 8-bit variable, okay, if I say it is unsigned, that means the range is 0 to 255. Okay, if I say that same 8-bit variable is signed, okay, that means it is having a range of minus 128 to positive 127. All right, now when you say that you have a unsigned addition, okay, for example, and you add two unsigned numbers together, and the value that you get, so if I take an 8-bit number, okay, and I add with another 8-bit number, okay, if the result is greater than 8-bit, okay, the final result is greater than 8-bit, then what happens is I will have a carry, okay, to indicate that this computation has resulted in an answer that cannot fit into an 8-bit variable. Okay, so I have an additional carry bit. Okay, so one of the questions I saw is, how do I know there's a carry? Where is it indicated? All right, so this concept of carry, okay, so all these concepts, okay, so there are a few different things: carry, overflow, negative, okay, all of these are what we call flags. Okay, what we call flags, which will be actually set in the hardware. Okay, and you will sort of appreciate this or understand this when we are going to the MIPS processor architecture. All right, so within the processor, okay, while the processor is computing, okay, and performing any operation, at the end of any operation, you will update these flags accordingly. All right, so at the assembly level, okay, when we learn assembly language, we will be able to check that a carry is being set or the overflow flag has been set or something like that. Okay, so with that, we will be able to interpret whether a carry has occurred. Now, this concept of overflow, okay, the same number of overflow in sign, what does that mean? Okay, the easiest way to interpret overflow is to look at it as to whether the answer makes sense. Okay, what do I mean by the answer makes sense? That means if I take a positive number, add with a positive number, and the resultant is a negative number, then it doesn't make sense. Same thing, if I take a negative number, add with a negative number, and the answer is positive, it also doesn't make sense. That is the easiest way of sort of understanding why or when the overflow flag is set. Okay, so simple example, if I give you this number 0 1 0 0 and 0 1 0 0. Okay, so this is in terms of decimal, this is decimal 4 and this is decimal 4. Okay, so 4 plus 4 will give me 8. Okay, give me 8. All right, now if I add this, okay, 0 0 1 plus 1 is 0 carry 1, 1 plus 0 is 1. Okay, so you can see that for this addition, okay, I have added two positive numbers. Okay, and the resultant is a negative number. Okay, now I interpret it as negative because I am currently telling you that I'm dealing with signed numbers. Correct? If I did not tell you that this is signed numbers, then if you treat it as unsigned, then the interpretation, it is fine. There is no issue. Correct? So in binary representation, it is still the same 0 and 1. It is whether we are looking at it as signed or unsigned. All right. So this is always sort of a confusion. All right, because in the binary, it looks the same. Correct? 1000 is still 1000. But on one point I say it's okay, the other point I say it is not okay. There is an overflow condition. Okay, so let me show you. Okay, let me show you this. Okay, where is it? Okay, wait, let me find my browser. Wait down. Okay, so I'm using this website called Online GDB. Probably you know about it. Okay, if you don't know, you can just put it in the chat here. Okay, so it's just a free online GDB compiler. You can create projects and run your projects there. It works perfectly fine. It works perfectly fine. All right. So there's no major issue with this. All right. So if you want to practice C programming, you don't want to download anything, you can just use this. All right. It works just as fine. Okay. So in this, okay, let's look at this code here first. Okay. So if you look at this code, all right. What I've done is I've declared a variable character with a value of 125. Okay, 125 character variable. All right. And what I'm going to do is I'm going to print out the decimal representation and the hex representation. So decimal is in or integer is in percentage D. In hex is percentage X. All right. And then after that, I'm running a loop. Okay, you have already covered loops right in your lecture. So I'm running a loop for 10 times. Okay, and I'm incrementing the number. Okay, as it goes. Okay, so let me run this and we see the result. Okay, so this is the result that we get. Now, if you look at this result, okay, what does it tell us? Okay, it tells us that I declared my variable 125 and 70. Okay, so if you open up your calculator, okay, again, maybe you've tried this, you have not. Okay, so in Windows, you have this built-in calculator, you can switch to programmer mode. Okay, then you key in decimal, you can automatically convert, okay, to anything here. So 125 in hex is 7D. Okay, so when I increment, okay, so 125, 126, 127, after 127 it rolls over. All right, now when it rolls over, what do I mean? Because 7f, when I add 7f with 1, it becomes 80. Okay, so in the binary sense, it is still going in the same way that we know, correct? After 7f, it adds 1, then it becomes 80. But because it is a default, by default, it is a sign variable. That means a character can only go from -128 to 127. So once I hit 127, it rolls over and it becomes -128. Okay, then -127, -126, and so on. Okay, so as far as the variable is concerned, okay, it is using 8 bits to store this data. All right, and this 8 bits is going to increment in the same sense. Okay, that means I'm still going to go, okay, in the same way. That means, okay, 7e, okay, 0x7e, 0x7f, and 0x80. Okay, but the only thing is 80 is now interpreted as -128. Okay, now if I were to change the way I view the number, okay, or the way I want the number to be represented, that means instead of declaring this as a character variable, if I put it as unsigned, okay, that means I am now telling the compiler that I'm declaring this variable, but it's an unsigned variable. That means I only want to store it as purely positive numbers. Okay, purely positive numbers. And now I save and I run again. Okay, now you see that there is no more negative representation. Okay, after 127, the 7F still became 80, still became 81, became 82. But after 127, it continued on 128, 129, 130, and so on. It stayed at purely positive numbers. Okay, so that is the concept of understand. The actual ones and zeros did not change. Okay, they are still the same. Okay, the number that we're representing is still the same. It is just that whether I want to make this ones and zeros to be viewed as a signed variable, unsigned variable, okay, depending on how I declare it. All right, so that is the underlying principle. That means we are looking at the binary, but that same binary, if you look at it from different perspective, it can relate to different things. Okay, so that is the sort of, I think, the common misunderstanding that I saw in the Slido. Okay, so there's a question, what would happen if we overflow an unsigned number? So for unsigned number, there is no overflow. Okay, it is just carry. Okay, it's either the carry bit is set. That means, okay, so maybe you're talking about overflow unsigned number as in you count all the way. That means, let's say I put it as 247. I know, sorry, 250. Okay. Then once you hit the maximum, you go back to 0. Why? Because for unsigned variable, it is 0 to 255. Okay, so it is count up to the maximum number of bits that that is allocated to it. So a character means it's 8 bits. Okay, so the maximum number of bits that it can hold will be 0 to 255 if it is unsigned, or negative 128 to 127 if it is signed. Okay. So again, this is I mean, from the questions in the Slido, I saw that this is one of the things that were not clear about. All right, so I hope this clears things up. Okay, then there was a few questions on the parity and error detection. Again, I think with ASCII code and so on. Okay, so generally, what is parity and what is used for? Correct. So in ASCII, for example, you have 7-bit data. Okay, or in any other case, if I have 7-bit data, and what I can do is I can pad an extra bit and call it a parity, which could be even parity, odd parity. All right. I mean, you can always read up on that. I don't want to go into the details of it, but the whole idea is you can add an additional bit, okay, that will help you. And how does that bit help you is, okay, so for example, okay, if let's say this is 0 1 1 0 1 1 0, okay, and if I say that I am using odd parity, okay, so when I say odd parity means the total number of ones must be odd. Okay, so in this case I have 4 1, so I add one more 1, so I make it 5, it's odd. All right, then I send it across a transmission channel. Okay, so in real life, when you send data across, okay, wired or wireless, whatever the case, there is always chances of data being corrupted, okay, bit flipping happening. All right, so there is no guarantee that what you send is what will be received. Correct, so the receiver always has the responsibility to do some form of error detection. Okay, the easiest way is of course parity. Now, if along the way, okay, assume that maybe this 1-bit flip. Okay, so if this 1-bit flip, then if the result that I get is 0 1 1 0 1 0 1, then this is the parity bit. Okay, no, this is supposed to be a 0. Okay, so only 1-bit flip. Okay, I think I draw it below here, easier to see. So 0, 1, 1, 0, 1, 0, 0. So this one bit flip. Okay, and the parity bit is still the same. Then what will happen? Okay, the receiver will see that I configure for odd parity, but I receive even number of ones. I receive even number of ones, which means that something went wrong. Okay, means something went wrong. So it will have to discard this. All right. Now, of course, this is a very rudimentary approach. Okay, because it only tells you that something went wrong. It can't correct the error because you do not know where is the error. Okay, and of course, the other flip side is it cannot detect even number of errors. Correct. If there is a double bit flip, that means if this one also had flip, then it will still come as odd number of ones. Then you have a false positive. All right. So it is not a foolproof system. Okay, but it's just something very very basic. All right. So again, parity error detection are again some concepts. Okay, but we're not going to the details of that in this module. Okay, so but since there was some confusion, some questions, I just wanted to cover that. Okay, so again, those are just the general stuff that I saw from Slido. Okay, but yeah, if later on you still have other questions, we can discuss that. Okay, so let's go through the quiz questions. Okay, so for the quiz questions, yeah, they asked for, I think the first quiz, it was quite easy. Just, I think mainly just trying to check on the syntax, okay, of things. And I think the correct answer, yeah, this is the correct answer. Okay, so every other thing had some issue. Okay, so for example, here, there is this semicolon here, the hex define, which you should not have, and some other, I think, errors. All right, but if you look at this is the full complete program where you first include your standard IO, okay, for your printf, scanf, and so on. Then you hex define, okay, whatever macros you want. Then you declare variables. Okay, and then here is a simple program to sort of enter some numbers and so on. Okay, so there's a question, why is the return type int? Okay, so this return type is usually in a sense, it is used by the operating system. Okay, because when you launch the executable, okay, you're actually running it as part of a sort of a process created by the OS. So you're sort of returning a value back to the OS. All right, but in most cases, it doesn't matter. Okay, or what return value this is. Okay, so it is just by default that because the operating system sort of forks this out, we return integer. Okay, so for this program here, okay, I think most compilers, if you put void, it still works. Okay, you put integer, you put void, it will still work for the return. Okay, I think you don't need to be too concerned about that. Okay, so this is another question. Okay, again, this was all, I think, just testing on the basic syntax, okay, and structure of a C program. Okay, so let's go through the questions on the loop, okay, so that you understand how to analyze this. Let me open up that. Okay, so maybe before that, I have some other questions that maybe we can try. Okay, so I've prepared some short questions here just to recap some concepts. Okay, so can somebody tell me what would be the answer for this? Okay, 2.0. Okay, correct. So everybody understands the concept, okay? And why is it 2.0? Because here you are doing a integer division divided by, one integer divided by integer. So even though I cast it to float, the cast to float happens after the division is done. Correct. So it doesn't help in the division, all right, but it just casts it to a float. So when I do the 10 divided by 4, it already gives me an answer of 2. So the float just makes it 2.0. Okay, so that's what I get here. Okay, let's try another question.
Okay.
Okay, so I'm getting 1 minus 1, 1. Okay, so most of you saying 1. Okay, let's just run this. Okay, so D is 1. So how do we get 1? So in case anybody is not sure. So basically what is happening is these are Boolean operations, correct? That means it's true, false. So only 0 is false. Anything other than 0 is considered true. So this is true and true. So if true and true means this is true. Okay, or with C is 0, which is false, but not of false is true. So true or true, then the answer will be true. Okay, so true will be 1. So D is 1. Okay. Okay, good. Let's go on to the next question here. This one you probably need to convert. So this is in hexadecimal. 0x means it's hex. Okay, so there's a question, can it return any other number other than 1? No. When you're doing Boolean, it's either 1 or 0. Unless you're doing what is called logical operations. Okay, if you're doing logical operation, then it will be a bitwise operation. Okay, so 34 and 8. Any other answers? So basically, you have a value 0x11, and here I'm printing to two variations. One is to the shift to the left of 1, shift to the right by 1. Okay, so so basically what is happening is, so 0x11, okay, in terms of binary will be 00010001. Okay, so when I shift left to the 1, so everything shift left to the 1, so it become 00100010. Okay,
so in the new line, value 1, if you specify value 2,
yeah.
will be a decimal type. Now,
Sorry, I have a question.
this one.
Okay, if you are shifting to the right by 1, so this last bit here, when you shift right, it will move out of the variable, so it will no longer be part of this, okay, 8-bit value that you have. So what will have is this will shift to the right, so we'll have 00001000. That is if you shift right by 1. Okay, so this will be 1, 2, 4, 8, 16, 32. So this will be 34, and this will be 8. Does anybody have any questions about this? Yeah, shift left and shift right is equivalent to multiply and divide by 2. Every time you shift left, is equivalent to multiply by 2. You shift right is divide by 2. Okay, but of course that divide by 2 and multiply by 2 makes sense only when all the bits are still part of the result. So in this case, for example, when I shift right, one of the bit is out of the variable already, so it's no longer divide by 2, right? Because one bit has disappeared. Okay, yeah, okay, yeah, so let's come back to this loop question. I mean, there's a question whether we can chain operators and if we hit the overflow. Okay, like I said, okay, when you shift, when you do any form of operation, the concept of overflow is how we relate to the declaration of the variable. Okay, so if you declare it as sign and you perform some arithmetic and then there is a change, then it will, let me see, if there is a change in the MS bit, then it will automatically reflect as a positive or a negative. Correct. Again, the detection of the overflow is not something you will see now, all right? And the logic behind it is something you will probably see when we do the MIPS design. Okay, at the lower level hardware, you will see that overflow and carry more obviously. Shift right is divide by 2. Okay, you can just try any number. Correct. If I say 1100, okay, this is 12. If I shift right by 1, it will become 0110, which is 6. So this is 12. 6. If I shift right by 1 more, it becomes 0011, which will be 3. Okay, the same thing goes when you multiply. I mean, when you shift left, okay, it will be multiplying by 2. Okay, so let's come to this. Okay, so usually this kind of questions, of course, if you key it in and you analyze. I mean, if you key in your compiler and you run it, you get the answer. All right. To analyze this and get the answer, of course, take some time. Okay, and these are the kind of questions probably if you want to torture you in the midterm or what we will set. Correct. Just to make sure you spend some time cracking your head and trying to figure out what's the answer. Correct. Okay, so the easiest way to, of course, analyze this is you list out the variables and you go through step by step. Okay, so the key variables here are I, J, yeah, and then whether we're going to do the printf. Okay, so I is the outer loop, so the very first time I is 0, J is 0, then you will print 0 and 0. All right, and then if J is greater than 1, then you continue. So in this case, you will not continue. All right, okay, because J is still 0, so you will print out book. Okay, and then you will come back. So once I finish the inner loop, then I go back and start the next iteration of the inner loop. So J is 1. So I'll print out 0 and 1. And again, J is not greater than 1. So again, I'll print out book. Okay. And then the next iteration, 0 and 2. Okay. And then so I'll print out 0, 2. But since J is greater than 1, I will continue. That means this condition is satisfied. Okay, so this condition is satisfied, so I will continue. So when I say continue means I will skip the rest of the code that is part of this current loop. That means I will skip all of this and come to the end of the current loop. Okay, and since I already complete 3 iterations of this loop, okay, I will be able to come out of the inner loop and go to the outer loop. So in the outer loop, I will check if I greater than 0. So currently I is still 0. It has not incremented. It will only increment when I go back and start the next iteration. All right, so I'm still currently I is 0. So I will go back, I will start the next iteration. So the next iteration will be 1, I is 1. Then the same thing will happen, J is 0. So again, 0, 0, boop. Okay, 1, 1, boop. Sorry. Okay, and finally, sorry, I'll just print 1, 1, 1, 2, and then I will continue. So when okay, so I getting some message that the internet connection is unstable. So if in the event that the Zoom gets cut off, just stay for a while, I'll come back in. Okay, so once I finish this second iteration, I'll come here. Then now I will satisfy this condition. All right, because now I is greater than 0, so I will break. So when I break, I will break out from the outer loop, then there's nothing else to do. Okay, so that is basically the way I analyze this. Okay, does anybody have any questions you want to ask? Okay, then we can go on to the next question. Okay, so again, this is the same thing. You just list out everything and you analyze step by step. I think it's tedious. Okay, it's tedious, but I guess it's probably the easier way to do things. Okay, so the very first time I is 0. Okay, J is 0. So once I come into the loop, X is originally 0, X will become 1. So J percentage 2 is 0. So since J percentage 2 is 0, not of 0 is 1. So if it is 1, that means it's true, so I continue. So if I continue, so y does not get updated. So y is still 0. Okay, then I go back and I start the next iteration of the loop. So 0 and j is 1. So when j is 1, then x becomes 2. Okay, so 1% 2 will be 1. Correct, and not of 1 is 0. So if it is 0, then I do not continue. Then I perform the addition. Okay, so when I perform the addition, so sorry, I should put 0.0. This is a float. Okay, so when I perform the addition, y plus equals to x over 2. So 2 over 2 will be 1, so I'll become 1. All right, and then you continue so to the next iteration. So 0, 2x is 3. So this again becomes 0. And so since j percentage 2 is 0, then not of it will become 1. So I will not compute this. All right, then the next iteration of the loop. Okay, and this will become 1 again. So now I add on, correct? So become 4 divided by 2, 2, 2 plus 1 is 3. Okay, and then the next iteration, the x is 5, this is 0, and then I will skip, so it become this. All right, and then once I finish the inner loop, when I come out to the outer loop, okay, I is 0, 0% 3 will be 0, so not of 0 will be 1, which is true, so I will break. Okay, then I will not continue anymore. Okay, so the final value of x is 5, and this is 3.0. Okay, so again, it is nothing special here. All right, it's just tedious. All right, it's just tedious because you need to go through step by step and analyze everything. Okay, to get the final answer. All right, other than that, I think it's just to make sure the concept of the loops is there. Okay. Okay, so now let's go on to the questions on the number systems. Okay, so if I want to represent 15,000 values, what's the minimum number of bits? So basically you need log to the base 2, the ceiling of it. All right, I think this one you should know, okay, from the slides. All right, so log to the base 2, 15,000 would be 13 point something, and then the ceiling of it is 14. So you need minimum of 14 bits to represent 15,000 different values. Okay, so that is the first question. I think fairly easy. Okay, what is 2120 base 3 in base 6? Okay, so 2120 base 3 in base 6. So the way to do this, okay, so we know we have 2120 and you want to go to base 6. Okay, so the easiest way always is to convert to base 10 first. Okay, because from base 10 you can easily convert back to any other base. All right, so to convert back to base 10, you do the normal multiplication, correct? So you take 3 to the power of 0 times 0. Then this is 3 to the power of 0 times 2, 3 to the power of 1 times 1, and 3 to the power of 2 times 2. Okay, then you add up everything together. Okay, so you will get 69 to the base 10. Okay, and once you get it in base 10, okay, it's easy to convert to any base because you just do the repeated division. So 69, if I divide by 6, I'll get 11, remainder 3. Okay, then again, divided by 6, I'll get 1, remainder 5. All right, and that will be your answer. So it will be 1, 5, 3 in base 6. Okay, so always when you want to convert from one base to another base, if you convert it to base 10 first as the intermediary, then subsequently you can just do the repeated division by that new base to get the final answer. Okay, so again, all of this is from your notes. Okay, so I think should be easy to follow. Okay, so I think all these slides, don't worry, I think Colin will upload. Okay, so find 01001010 8-bit. The base. There's a question here. The base of Q1, is it base 2 by default? Okay, usually for most cases, if the number is just written as it is without a base, we take it to be base 10. Okay, the normal decimal numbers. All right, unless if it's any other base, we will usually put a base number next to it. Okay, so this is the question here, 01001010, and it asks to convert it in 2's complement. So in 2's complement, okay, so this answer is already positive. All right, this answer is already positive. So an answer that is positive in 2's complement is still the same. Okay, when the answer is having the most significant bit as 1, and then you want to find the actual value, that is when you need to do the 2's complement one more time to get the actual value. Okay, for example, okay, so let me show you an example. What do I mean by this? If let's say I give you this binary number, right? 01010010. Okay, and I tell you, okay, this is base 2, and I ask you what is the base 10 equivalent of this. Okay, so let's just make our life easy. I just use my calculator here. So 1010010. Okay, so the decimal equivalent here is 82. Okay, decimal equivalent here is 82. So I can straight away come here and say that this is 82 in base 10. Okay, but if I were to give you another binary number, okay, let's just say I put a 1 in front, 0, 1. Okay, and I say this is a 2's complement number. Okay, I tell you this is a 2's complement number. Can you give me the decimal equivalent, the base 10 equivalent? I cannot key in this in my calculator and convert like that. Okay, I cannot key in 11010010. Sorry, in binary. Okay, so 11010010. Okay, I will get it as decimal 210. Okay, but I know this is wrong. Okay, I know it's wrong. Why? Because it is a 2's complement number, and if it's a 2's complement number, that means this is actually my sign bit. Correct? That means it's supposed to be a negative number. So I can't just key this into a calculator and expect to get the correct answer. It's not going to work. Only if the most significant bit is 0, then it works. Okay, because it's a positive number. Okay, but if the most significant bit is 1, then it's not going to work. So what do I need to do? Can anybody tell me what I need to do? If I want to find the base 10 equivalent of this 2's complement number. I need to do another 2's complement one more time. Okay, I need to do another 2's complement one more time. That means I flip everything 0, 0 1 0 1 1 0 1, and then add 1. Correct. So this is 0 31 1 1 1 0 1. Okay. Now what I can do is I can take this. Okay, let me just confirm whether I flip correctly. 0 0 1. Then I add 1. Okay, now this binary, which is 101110, I can key in my calculator, and that gives me a value of 46. Okay, so that gives me a value of 46, but I still have one more last step, which is this. Then that is my final base 10 answer. So always remember, if the most significant bit is 0, then you can directly use the calculator. If it is 1, then you must do the 2's complement one more time to get the actual value. Then you put a negative sign in front of it. That gives you the true base 10 value of that 2's complement number. Okay. Okay, so this is again another example. Okay, so to find 2's complement, you just invert everything at 1. All right, so I think this one is quite straightforward. Okay, here they ask you to do an addition in a 8-bit 2's complement. So I think since both of them are positive, you add is fine. Should be quite straightforward. Right, 0 0 1 1 0 0 1 1 0 0 1 0 0 1 0. So this will be 1 1. Okay, so in this case, since there are 2's complement number, you're adding a positive number, another positive number, you get another positive number, is fine. So there is no overflow. Okay, so there's no overflow in this, it's fine. Okay, so this is excess 100 representation. So this excess 100 or excess 50 or whatever a number they put there, all right, basically means that this excess becomes your new 0. Okay, you treat it as your new 0. Okay, so when I say excess 100, that means effectively x plus 100 is my new 0. All right, that means that the smallest value that I can represent from there will be negative 100. Okay, negative 100, because x plus 100 is now my new 0. Okay, and that means the total number of negative values that I have is negative 100 all the way to negative 1, which is 100 negative values. All right, so again, this is just on the excess representation. Okay, IEEE 754. Okay, how to do this? Okay, so again, these are quite standard steps. Okay, so let's go through over here. So I have 12.5625. Now, first step is I want to convert to binary. So when you want to convert to binary, you need to do it separately, the whole number and the fractional part separately. Okay, so for 12 is quite straightforward, 1100. You can straight away calculate. Okay, now the fractional part is where you need to do the repeated multiplication by 2. Okay, so 0.5625 times 2 will be 1.125. So the 1 will be here. Then I start again, 0.125 times 2 will be 0.25. So that will be 0. Then 0.25 times 2 will be 0.50. And finally 0.5 times 2 is 1.0, which is 1. So this will be 1001, 1001. So that's the first thing. You convert it to the binary representation. Okay, once you convert to binary representation, then you must normalize it. That means you move the decimal point till you get it to be 1 point something. So that will be 1.1001 multiplied by 10 2 to the power of 3, since you move back by 3 decimal points. Okay, and the last step is the mantissa, which is 127 plus this number over here, which is 3, which will be 130. Okay, so once you get all of this, you just put it into the format. That's it. Okay, then you get the answer already. So the first thing is a sign bit. So the sign bit is 0. Okay, then the exponent is 130. So 130 is again 1000. Let me check this again. Decimal 130. 1000 0010. Okay, and then the last part here, okay, is the rest of the bits after the decimal point. So it'll be 1001 and the rest are all zeros. Okay, the rest are all zeros. Okay, and to convert to hexadecimal, you just group them into 4. So 0, 1, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 0, 0, 1, and the rest are all 0. So this would be 4, 1, 4, 9, then 0, 0, 0, 0. That will be base 16. Okay, so it's the same steps. It's just again tedious. You need to do it step by step. But other than that, I think if you follow the steps, it is you should be able to get it right. Okay, so any questions on the IEEE format? Okay, again, all these are just the same things that we did just now. Okay, so the rest is okay. So basically, we have covered all the questions you wanted to cover, and now I have some. Okay. I have some practice questions. Okay. Again, these practice questions are to help you maybe just revise and sort of become more proficient with some of the concepts of the C programming that is covered in class. All right. If we do it together, I think it will help you. Okay. So let's try the first one. Okay. So there are 2 questions. I'll just try one, and the other one probably you can try it on your own. Okay. So you can open up any editor that you have to try this. Okay. So basically, what we want to do is we want the user to enter unlimited numbers. Okay. But these numbers are accepted only if they are valid. All right, and valid numbers are in the range of 0 to 100. Okay, so I terminate the input by entering 999, and after that I compute the average of all the valid numbers. Okay, so I'll give you a few minutes to start off first. All right, and so I still don't have the solution to this, so I'm going to do it together with you all just to go through the process, okay, so that we understand how to apply all the things that we have learned in C so far. Okay, but I'll give you a few minutes to start first, and then we will do it. Okay, I'll join you all. Okay, so there's a question, how do you express 0 in IEEE? So 0 in IEEE will still be all zeros, all right, because the binary representation of 0 will still be 0. So the exponent multiplication will all be 0. Okay, so let me do this together with y'all. Okay, I don't have a solution, so I'm also doing it right now with y'all. Okay, so okay, so to do this, you are going to have a loop, all right? But since you do not know how many times the loop will run, all right? Usually, what we will do in this case, you will use what we call a while one loop. Okay, so a while one loop is what we call a forever loop. Okay, and it will run indefinitely till some exit condition is met, and then we can break. Okay, so you can use a while one loop or you can use a do while loop. Either way is fine. All right, we only use for loop when we know exactly how many times we want to run the loop. Okay, so after you prompt the user, you can do a scanf. So in this case, you want to check for it being a valid, and you have two conditions, correct? Input must be between 0 and 100, correct? So input must be greater than equal to 0, and input must be less than equal to 100. Okay, so that is how you have multiple check, correct? You have one condition, and this is double n, so n the second condition. So for the first condition and second condition, if both of these are valid, okay, then it is, I mean, both of these are true, then it's a valid input. then I can add the sum inside. Okay, so if I were to key in any other number, okay, I can probably put a printf message, correct? Say invalid range or something. Okay, so ask the user to key in, enter, check the range. If it's a valid range, you sum up. Okay, so the initial value of sum is 0, correct? And then you add up. Okay, I can maybe put it as a float. It's easier later when I do division. Then if not, I say invalid range. And probably before that, I can check whether it's 999, correct? If input equals to 999, and break. Then don't do anything else. Yeah, so I mean, for now, you don't need to worry about any integer overflow. All right, you just assume that you will be able to store, or the sum will be able to compute. Okay, so coming back to the question of the 0 in the IEEE. So 0 is considered a special case. Okay, so in the IEEE format, what we are covered in class is the all the typical use case numbers. All right, but 0 is considered a special case number. So the IEEE format already has set aside provision to handle special cases. So if the number is 0, it will automatically code as all 0. Okay, so basically this loop should run, and once I exit from the loop, then I can compute the average, correct? Then I can print out. Yeah, so I also need to keep track of the count, correct? Yeah, so I need to keep track of the count. Where I need to divide by the total number of valid inputs, correct? So only if it is valid, I do a plus here. Okay, so again, I don't know whether it's fully correct, but scan. Okay, that's right. Okay, so this is a bug, correct? It tried to compute the average even when there's no input. So I need to add some additional error checking there. Okay, okay, let's try again. Okay, seems okay. Yeah, seems okay. Yeah, so just now I used char, it should be integer for input and for count. Again, this is just one possible solution. Like I said, instead of while one loop, you can use a do while loop. Okay, so in a do while loop, you would run the first iteration of the loop, and then you will do a check at the end of the loop. Okay, to decide whether to continue. In my case, I just use a while one loop and I break. Okay, so either way is fine. Okay, so this is just again a basic example just to make sure you practice some of those C syntax. Okay, I mean programming wise, I'm sure all of you are very good. All right, it's just that it's a new language, so you just need to get the syntax, familiarize yourself with the syntax, so that you know how to use it correctly. Okay, so let me. Does anybody have any questions you want to ask about my code over here? Okay, when you input a non-integer, okay, it will still be captured, if I'm not wrong, based on the ASCII value that it represents. Okay, so for example, if I key in A, so the program just runs indefinitely. So I guess that somehow the scanf doesn't quite capture the interpret the character correctly. Yeah. So I guess when you enter a character, somehow it gets stuck in the scanf, in a sense that it runs the loop indefinitely. That means it always assumes that there is a new input from the user, but it is still holding on to the old or the first input that it keyed in. Okay, so again, that could be some issue with how the scanf captured the character when it's declared as a integer. Is there a way for us to type check? Okay, so there are other ways of capturing inputs. Okay, again, we do not go into all of that yet. Okay, so there is you can get string, get character, and so on. So there are other input mechanisms. So scanf is just one input way of getting. So you can go and check for other ways. Okay, so there's get character, there's get string. Okay, so there are different ways in which you can capture user input and then do some checking before you validate that it is acceptable. All right. Again, those are things that probably not covered in this range of topics that we have for this module. Okay, but you can go and read up on that. Okay, get S, get CH, and so on. Okay, so that will help you to probably validate the input before doing any other processing. Okay, so just one more thing before we end. Okay, so this is the second example, which is a calculator, which I think is something you can try on your own. Correct? Just create a simple calculator, get some inputs, perform the necessary operation, plus, minus, times, or divide, and so on. Okay, so I will leave that for you to try. Okay, there's just one more last exercise, let's say example. Okay, for us to just understand the impact of the binary representation. Okay, and how it sort of affects some of the things that we do. So if I look at this code over here, okay, I've declared a float variable 0.0 and I've written a loop. Okay, while x not equals to 1.0, x plus equals to 0.1. All right, so when I look at it from the mathematical sense, if I keep incrementing, after 10 times I'll hit, all right, 1.0, which will mean that I will be able to exit from the loop. Okay, but why this loop may never end? Okay, when we look at it from the binary perspective. Okay, if I take 0.1, okay, and you do your representation, correct, your representation in binary, okay, what you will see is that it comes down to this continuous infinite repetition of 0011 all the way. So initially 00011, then it is 0011, 0011, and so on. Okay, so what we see here is the number 0.1 can never be fully represented in binary because it's just continuously repeating the binary. All right, so eventually, of course, since we truncate to representing it by a certain number of bits, there will always be some finite error at the end. All right, so it will never be exactly represented. There will always be some amount of error. Okay, so which means that, okay, in this, when, okay, again, depending on how many bits I use, the more bits I use, of course, the more closer it is, but there will always be some error. So if I use 32 bits, okay, that means the closest that I will get, okay, when I run this loop, it will be this number, 0.0999, whatever, okay? And then when I add, okay, I mean, when 0.1, the closest I can represent is this, and when I add 10 of this, I will get this 0.99 all the way, okay, as you see here. Now, if I add one more, if I go through the loop one more time, I will overshoot, okay? And in essence, what it means that it will never become 1.0. Can never become 1.0. It's either slightly below that or slightly above that. All right, so that is again one of the things that we don't normally think about when we write code, correct? That the way it is represented can actually be impacting the way the code is run, even though mathematically it makes perfect sense. All right, but because in the hardware world, we are limited, correct? And since some numbers like this can never be exactly represented, which means there will always be some error. Okay, so you may never be able to actually represent 1.0 in this case. Okay, so again, this is just, I would say, to get you thinking about why this is important, all right? Because when you just write software and sometimes things don't work the way we expect it to work, okay, it could be reasons that beyond just the software, could be the underlying hardware or the way data is being represented in the hardware, okay, that is affecting how the actual software is running. Okay, so again, these are things that we hope that this module will sort of make you realize. Okay, so again, someone has shared this Stack Overflow thing here on why scanf enters. Okay, okay. I think this one you can all go back home and read about it. Okay, so is there anything else that you all want to ask or clarify? Okay, so again, C programming part, I would say, is actually the easier part of this module. Okay, once we go into assembly and MIPS, it gets, I mean, again, depends on how you take it. It gets more challenging. All right, there are a lot more new stuff to learn. Especially when you go into assembly language and the processor architecture and so on. Okay, but and I know the workload is heavy. All right, so you need to be consistent. Okay, you need to be consistent. If not, once you miss one week of lectures, already you feel that you cannot catch up. Okay, because everything is progressive. Okay, everything links up. So you need to keep up with the pace. Okay, then only you can sort of understand what's going on. Okay, so I will end here today. I will still be online. For those of you who have any questions that you want to ask, feel free to ask. If not, thank you, and I will see you all next week. Okay, so you say you can't open the PDF files after downloading. Okay, that's strange. Did you try using some opening with some other application besides Adobe or anything like that? Okay, then I don't know, it sounds strange because nobody else reported any issues with downloading the PDF files. Yeah, I'm not sure what could be the issue because there's no other case of this. Did you try other files for other modules? Okay, so there's so there are no practical coding tests. Okay, there are no practical assessments from what I see so far. Okay, the labs will require you to do some coding and so on, but I think that one should be fine. But assessment wise, there is no practical test. Okay, there's another question. Since there are different representation of numbers, how do you know how it is taught? Okay, so the thing is, ultimately it is all the same, right? It's all ones and zeros, right? So like I said, it all comes down to how we declare and interpret the variables, right? So if I declare it as an integer or I declare it as a float, then I expect the variable to behave in a certain way, correct? That means this is the range, this is what it can support. Okay, so just like how if I declare integer variable, I do not expect it to store decimal values for me. All right, but ultimately, to an integer and a float may look the same in terms of binary, correct? But the way it is interpreted, depending on how I declare the variable, is how I view it. Okay, so ultimately, I think at the higher level, we declare the variables and we use them as per what we want, correct? And the lower level hardware will take care of the representation for us. Okay, will there be solutions for all the I I mean the solution, I have to check with Colin to see whether he's going to upload that. Okay, I mean the slides, I think we will upload. The solution, I think he will upload. I'll check with him. Okay, I can't open the zip file. Okay, Nathaniel. Okay, I really do not know what could be the issue. Because if it was a file issue, then I think everybody would be having it. So, but you are having this issue, so I really can't think of the reason. Maybe you can just ask Colin again and see whether he's going to upload any other version to see whether it works for you. Okay, so does anybody have anything else you want to ask? Okay, so for one's complement, the additional carry bit is the way you do one's complement is when you have an additional carry bit, you need to bring it back in to complete the whole operation. All right. Whereas for two's complement, since you already complemented and added the one, so whatever carry that you get at the end is considered an additional carry bit beyond the range of bits that you have. Yeah. So I mean, in a sense, you can think of it that this is the process of how the computation is done because of the way the number is represented. Okay, so I'm going to drop off now. If anything, you can WhatsApp me if you want to clarify anything. Okay. Bye.